Discussing the large-scale structure of the cosmos, astronomers sometimes say that space is curved, or that the universe is finite but unbounded. Whatever are they talking about? Let's imagine that we are perfectly flat. I mean absolutely flat, and that we live, appropriately enough, in a flatland, a land designed and named by Edwin Abbott, a Shakespearean scholar who lived in Victorian England. Everybody in Flatland is, of course, exceptionally flat. We have squares, circles, triangles, and we all scurry about, and we can go into our houses and do our flat business. Now, we have width and length, but no height at all. Now, these little cutouts have some little height, but let's ignore that. Let's imagine that these are absolutely flat. That being the case, we know, us Flatlanders, about left-right, and we know about forward-back, but we have never heard of up-down. Let us imagine that into Flatland, hovering above it, comes a strange three-dimensional creature which, oddly enough, looks like an apple. And the three-dimensional creature sees an attractive, congenial-looking square, watches it enter its house, and decides in a gesture of interdimensional amity to say hello. "Hello," says the three-dimensional creature. "How are you? I am a visitor from the third dimension." Well, the poor square looks around his closed house, sees no one there, and what's more, has witnessed a greeting coming from his insides, a voice from within. He surely is getting a little worried about his sanity. The three-dimensional creature is unhappy about being considered a psychological aberration, and so he descends to actually enter Flatland. Now, a three-dimensional creature exists in Flatland only partially. Only a plane, a cross-section through him can be seen. So when the three-dimensional creature first reaches Flatland, it's only the points of contact which can be seen, and we'll represent that by stamping the apple in this ink pad and placing that image in Flatland. And as the apple were to descend through, slither by Flatland, we would progressively see higher and higher slices, which we can represent by cutting the apple. So the square, as time goes on, sees a set of objects mysteriously appear from nowhere and inside a closed room and change their shape dramatically. His only conclusion could be that he's gone bonkers. Well, the apple might be a little annoyed at this conclusion, and so, not such a friendly gesture from dimension to dimension, makes a contact with the square from below and sends our flat creature fluttering and spinning above Flatland. At first, the square has no idea what's happening. He's terribly confused. This is utterly outside his experience. But after a while, he comes to realize that he is seeing inside closed rooms in Flatland. He is looking inside his fellow flat creatures. He is seeing Flatland from a perspective no one has ever seen it before to his knowledge. Getting into another dimension provides as an incidental benefit a kind of X-ray vision. Now our flat creature slowly descends to the surface, and his friends rush up to see him. From their point of view, he has mysteriously appeared from nowhere. He hasn't walked from somewhere else. He's come from some other place. They say, "For heaven's sake, what's happened to you?" And the poor square has to say, "Well, I was in some other mystic dimension called up." And they will pat him on his side and comfort him, or else they'll ask, "Well, show us, where is that third dimension? Point to it." And the poor square will be unable to comply. But maybe more interesting is the other direction in dimensionality. What about the fourth dimension? Now, to approach that, let's consider a cube. We can imagine a cube in the following way. You take a line segment and move it at right angles to itself in equal length. That makes a square. Move that square in equal length at right angles to itself, and you have a cube. Now, this cube, we understand, casts a shadow. And that shadow we recognize. It's, ordinarily drawn in third grade classrooms as two squares with their vertices connected. Now, if we look at the shadow of a three-dimensional object in two dimensions, we see that, in this case, not all the lines appear equal. Not all the angles are right angles. The three-dimensional object has not been perfectly represented in its projection in two dimensions, but that's part of the cost of losing a dimension in the projection. Now, let's take this three-dimensional cube and project it, carry it through a fourth physical dimension. Not that way, not that way, not that way, but at right angles to those three directions. I can't show you what direction that is, but imagine that there is a fourth physical dimension. In that case, we would generate a four-dimensional hypercube, which is also called a tesseract. I cannot show you a tesseract because I and you are trapped in three dimensions. But what I can show you is the shadow in three dimensions of a four-dimensional hypercube or tesseract. This is it. And you can see it's two nested cubes, all the vertices connected by lines. And now the real tesseract in four dimensions would have all the lines of equal length and all the angles right angles. That's not what we see here, but that's the penalty of projection. So you see, while we cannot imagine the world of four dimensions, we can certainly think about it perfectly well. Now, imagine a universe just like Flatland, truly two-dimensional, and entirely flat in every direction, but with one exception. Unbeknownst to the inhabitants, their two-dimensional universe is curved into a third physical dimension, maybe into a sphere, but at any rate, into something entirely outside their experience. Locally, their universe still looks flat enough, but if one of them, much smaller and flatter than me, takes a very long walk along what seems to be a straight line, he would uncover a great mystery. Suppose he marked his starting point here and set off to explore his universe. He never turns around and he never reaches an edge. He doesn't know that his apparently flat universe is actually curved into an enormous sphere. He doesn't sense that he's walking around a globe. Why should his space be curved? Because there's so much matter in this universe that it gravitationally warps space, closing it back on itself into a sphere. But our Flatlander doesn't know this. After a long while, you'll find he somehow returns to his starting point. There must be a third dimension. Our Flatlander couldn't imagine a third dimension, but he could sure deduce it. Now, increase all the dimensions in this story by one, and you have something like the situation which many cosmologists think may actually apply to us. We are three-dimensional creatures trapped in three dimensions. We imagine our universe to be flat in three dimensions, but maybe it's curved into a fourth. We can talk about a fourth physical dimension, but we can't experience it. No one can point to the fourth dimension. I mean, there's left, right, and there's forward, back, there's up, down, and there's some other direction simultaneously at right angles to those familiar three dimensions.